Hi, for today I will discuss the definition of random variable, discrete, and continuous random variable. Let's start first with random variable. In statistics, a random variable is a function that can take on a finite number of values, each with its own probability, or an infinite number of values. The probabilities of which are summed by a density function. It is defined in order to account for all possible outcomes of an event when it's used to examine random events. A random variable is one whose value is determined by the numerical outcome of an random event. A random variable is denoted with a capital letter. The probability distribution of a random variable x tells what the possible values of x are and how probabilities are assigned to those values. A random variable can be discrete or continuous. One example of a random variable is the outcome of a coin toss. So next, I will discuss the discrete random variable. A discrete random variable x has a countable number of possible values. The probability distribution of a discrete random variable x lists the values and their probabilities, where value x1 has probability p1, value x2 has probability x2, and so on. Every probability pi is a number between 0 and 1, and the sum of all the probabilities is equal to 1. Example of it is number 1, the number of people going to a given soccer match. Number 2, the number of students that come to class on a given day. And lastly, I will discuss the continuous random variable. A continuous random variable is a random variable where the data can take infinitely many values. For example, a random variable measuring the time taken for something to be done is continuous since there are an infinite number of possible times that can be taken. That's all. Thank you.
Good day. I do want to talk about properties of discrete probability distribution. So this is how you write all probability is 1, or all probability is equals to 1. Well, you can write it like this, but this is recommended because it makes you seem professional. Okay. I do want to point out why this one is not a probability distribution, because simply it has -1 on its fraction. Okay, let's move on to the real problem. So as you can see, number 4 is missing. So how do we get number 4? So what we'll do is add all of this here. So 0.6 plus 0.23 plus n plus 0.05 plus 0.7. Okay, as we add all of them, it has the sum of 0.41 equals to 1, since all probability is equal to 1. Okay, so we have to put this at this side. For it to become negative. Okay, 1 minus 0.41 is equals to 0.59. Okay, let's move on to the next. So how do we find this? Since it's looking for 6 greater than 6 or is equal to 6, we have to get P6 plus P8. So from this chart right here, we'll get 0.5 and 0.7 because we need those. So 0.065, plus 0.7 is equals to 0.12. So that's the answer. Simple, right? Let's do another one. So how do we find C? So basically what we'll have to do is P2 plus P4 plus P6. So from the chart, we'll be writing down 0.23 plus 0.59 plus 5. 0.5, So we'll be adding all of those, and the sum is 87. So that's how you get the answer. Basically, to sum things up, basically what you have to do is just add all of them and you'll get your answer. That's all, thank you.
Hi, I am Carl Alegre. For today's topic is the mean, variance, and standard deviation of discrete probability distribution. Now let's identify what is mean, variance, and standard deviation and their formulas. For this mean, the mean of discrete probability distribution is given by m or mu equals sigma x times p of x. Next is for the variance. Variance is given by formula of sigma squared equals sigma x squared times p of x minus mu squared. And the last is standard deviation. We need to get first the mean and the variance to get the answer of standard deviation. Now let's find the mean, variance, and standard deviation in a problem using table. Here is the given of the probability distribution table. The first column is x, which refers to possible values of random variables. And the second column are its responding probabilities, and these both table are given. To get the mean, we add another column. Also, we have a guide, which is the x times p of x. The first one, 11 times 0.25, it will give us 2.75. Second one is 12 times 0.23, it will give us 2.76. The next one is 13 times 0.17, it will give us 2.04. The next one is 14 times 0.13, it will give us 1.82. And the last one is 15 times 0.11, it will give us 1.65. Then after that, we add all the result in column of x times p of x, and it will give us the mean, which is 11.02. To get the variance, we need to add two columns. The first column that has a guide of x squared. The first one is 11 squared, it will give us 121. The second one is 12 squared, it will give us 144. The next one is 13 squared, it will give us 169. The next is 14 squared, it will give us 196. And the last is 15 squared, it will give us 225. For the second column, for the variance, is this, which have a guide of x squared times p of x. The first one is 121 times 0.25, it will give us 30.25. The second one is 144 times 0.23, it will give us 33.12. The second one is 169 times 0.17, it will give us 28.73. The next one is 196 times 0.13. It will give us 25.48. And the last one is 225 times 0.11. It will give us 24.75. To get all the final answers, we need to use again the formula for the final answer for variance. And square root the result, and that is the standard deviation.
Converting from a normal distribution to a standard normal distribution and vice versa. A z-score table is a precise location of each x variable within a distribution. It measures the distance between the observation and the mean. Now we are going to use this formula, which the variable z stands for standard normal score or z-score, while x is any data value in a normal distribution. The symbol mu means mean, and lastly, this symbol is standard deviation. If the z-score is positive, then that means that the core is above the mean. If the z-score is 0, this means that the score is the same as the mean. If the z-score is negative, this means that the score is below the mean. Now here's the example number 1 with the mean of 16 and a standard deviation of 3 and a normal variable of 12. Now as you can see in this image, I replaced the formula with the given and proceeded to subtract 12 minus 16 and divided by 3. Now that's why I got the answer negative 1.33. The z-score is negative. That means that the score is below the mean. And example number 2, the given of mean 19 and standard deviation of 6 and a normal variable of 22. Now as you can see again here, I replaced the formula with the given variables and proceeded to subtract the mean with the normal variable and then divided it with the standard deviation 6, and I got the answer 0.5. Now, as you can see, 0.5 isn't actually equal to 0. It has a 0.5. So that means that the z-score is above the mean. Now, in this new slide, you can see that you can see here the formula in converting standard distribution to a normal distribution. The formula consists of x equals mean plus standard deviation multiplied by z. Now, convert the following z-score to an x variable. Here are the given. We have a given mean of 38, a standard variable of 5, and a z-score of 22. As you can see in the image, I replaced the formula with the given variables. X equals 38 plus 5 multiplied by 22. Now, you should first solve the variables with the parentheses. So, 5 multiplied by 22 equals to 110. Now, add it with the mean. So, 38 plus 110 equals to 148. Second example, convert the following z-score to an x variable. The givens are the mean of 38, a standard variable of 8, and a z-score of 40. I replaced the formula with the given variables and became x equals to 38 plus 8 multiplied by 40. As the PEMDAS rule, you should always solve first the variables with the parentheses. So 8 multiplied by 40 equals to 320. Now, add it with the mean. 320 added 320 plus 36 equals to 356, and that's how I got the answer.
Welcome. In this video, I'll be showing how to solve for normal distribution. A normal distribution is a symmetric bell-shaped distribution where the area under the normal curve is 100 or 100%. The standard normal distribution, or what is called z-distribution, is a special normal distribution with a mean of 0 and a standard normal deviation of 1. Because of this, the standard normal distribution is always centered at 0 and has intervals that increase by 1. Each number on the horizontal axis corresponds to a z-score. As z-scores tell us how many standard deviation an observation is for the mean mu. For example, a z-score of -2 tells that I'm 2 standard deviation on the left of the mean. And a z-score of 1.5 tells us that I'm 1.5 standard deviation to the right of the mean. Most importantly, a z-score allows us to calculate how much area that specific z-score is associated with, and we can find out the exact area using z-score table, also known as the standard normal table. This table tells us the total amount of area contained to the left side of any value of the z-score. For this table, the top row and the first column corresponds to z values, and all the numbers in the middle corresponds to areas or probability. Standardization involves using this formula. This formula says that the z-score is equal to an observation x minus the population mean divided by the population standard deviation. Suppose that we are gathered data from last year's final chemistry exam and found that it followed a normal distribution with a mean of 60 and a standard deviation of 10. If I were to draw this normal distribution, we would have 60 located at the center of the distribution, because it is the value of the mean, and each interval would increase by 10, since this is the value of the standard deviation. To convert this distribution to the standard normal distribution, we will use this formula. The value of the mean is equal to 60, and the value of the sigma is equals to 10. We can then take each value of x and plug it into the equation. If I plug in 60, I will get the value of 0. If I plug in 50, I will get the value of -1. And if I plug in 40, I will get the value of -2. If we do this for each value, you can see that we end up with the same value as the standard normal distribution. Thank you.